Hello everyone and welcome back to Math Olympiad problem solving series. Now today we are going to find the remainder of a series, sum of series 9 to the power 10, 9 to the power 10 square plus up to 9 to the power 10 to the power 100. Now this particular series, when we divide it by 7, what will be the remainder? Okay, so the sum is a little bit big, but we'll use a number theory technique so that it will be very easy. Okay, so we are going to use Euler's theorem. So in Euler's theorem, it is given that if the HCF of these two numbers 9 and then 7 is 1, then we can use Euler's theorem. Now what is Euler's theorem? See, this is the statement. If the HCF of this particular A and this M is 1, then you can write a to the power 5 of m congruent to 1 modulo m. So what is the condition? The HCF of a and m should be 1. Then you can write this particular congruence. Now let us try to understand what is phi of m. Phi of m is not a function. Phi of m is equal to the number. This is a number, okay? Phi of m is equal to the number of natural number. So here phi of m is n, number of natural number relatively prime to what? M. Okay, relatively prime to m and not greater than m. So what we'll do, let us take a number, then you will understand. Suppose phi of 6. So we have to take numbers which are less than 6 because it is given, no, not greater than m. So 1, 2, 3, 4, 5. Now we have to check that which natural number, the HCF of which natural number with 6 is 1. Now see, if we take 1 and 6, HCF of 1 and 6 is what? 1. So we will consider this one. But when you take 2 and 6, the HCF of 2 and 6 is not 1. So we will not take this one. Similarly, we cannot take 3. Similarly, we cannot take 4. But 5 will come. So how many number? 2. Okay. So now let us take another number 5. So numbers which are less than 5 is 1, 2, 3, 4. Okay. So what are the number that we have to take? So 1 and 5 it will come because HCF is 1. 2 and 5 this is also come. 3, 5 it will come. 4 and 5 all will come. So how much? 4. Now from this we can understand that here P is what? P is a prime number. So if P is prime, then it is always how much? 1 less, P minus 1. But for composite number, it is something else. You see, we have taken 6, but the pi of 6 is how much? 2. But prime number, if it is pi of 5, then only 1 less. So just remember this definition, phi of m. Otherwise, you'll get a little bit difficulties in understanding the statement of Euler's theorem. Now let us go back to the problem. Since the HCF of here, our A is, this is our A, and this is what? M is 1. So we can use Euler's theorem. Okay, by Euler's theorem, what we can write is A means 9, 9 to the power 5 of m. So our m is how much? 7. 7 is prime number. So what I said, so if it is 7, a prime number, so it will be 1 less. So 9 to the power 6 congruent to 1 modulo 7. Okay. This result we can use. Now what is the first term? 9 to the power 10. So 9 to the power 10 congruent to. So we already have that 9 to the power 6 is how much? 1. So this 9 to the power 10 we can write 9 to the power 6, then 9 to the power 4. Okay, so if we divide 9 to the power 6 with the 7, so what will get? 1. So from 9 to the power 6 will become 1, and then 9 to the power 4 congruent to, so 9 to the power 4. So if we calculate 9 to the power 4, it is how much? 6561. Okay, 9 to the power 4. If we divide this by 7, no, if we divide this by 7, after dividing you will see that 2 will be the remainder. So when we divide 9 to the power 4 by 7, 2 is the remainder, modulo what? 7. You can simplify it. You can write 3 to the power 8. Like this also you can go. But it's easy. Now let us take the next number, which is 9 to the power 10 square. Congruent to this, we can write 9 to the power 10 to the power 10. Congruent to. So in the last line, we see that 9 to the power 10. You see 9 to the power 10 is congruent to how much? 2 modulo 7. So this 9 to the power 10, when we divide it by 7, we will get 2. So 2 to the power 10. 2 to the power 10 is how much? 1024. So again, if we divide it by 7, you just check it, you will get 2 as the remainder. So it will be how much? Congruent to 2 modulo 7. So I'm showing only 2. You can find others also. So when we divide 9 to the power 10 by 7, we get 2 as remainder. If we divide 9 to the power 10 square with 7, then also 2. So similarly, if we divide 9 to the power 10 cube, 10 to the power 4, or like 10 to the power 100, in each and every case, what we will get? We will get 2 as the remainder. Okay, by induction. So 10 to the power n. N can be number from 1 to 10, 1 to 100. So this is congruent to what? 2 modulo 7. What is n? N is a natural number. So always it is divided by what? When we divide it by 7, we will get how much? 2. Okay, so now therefore what is the series? Our series is 9 to the power 10, 9 to the power 10 square, then 9 to the power 10 to the power 100. So how many times we see here? 100 times. So in each and every time, if we divide this by 2, this by 7, you will get 2. If we divide this one by 7, you will get 2. So in each and every case, we will get 2 as the remainder. So how many 2 will come? 102 will come. Okay, 102 will come. So this is how much? 200. So if we divide 200 by 7, you will get 4 as the remainder, modulo 7. Okay, so this is the remainder. When you divide this whole series by 7, we will get 4 as the remainder. So 4 is the answer. So I hope you understand the solution. So for this kind of more problem, so kindly subscribe my channel and share with your friends. Thank you once again for watching.